Evaluation of integral of the form integral 0 to infinity e raised to at ft dt. Means if you want to evaluate integrals of the type, say for example I am writing an example here, evaluate integral 0 to infinity e to the power minus 2t sine square 2t dt. Okay, I want to evaluate this integral. So in this case what should I do here is, first of all there is another method also, but now we will do with the definition of Laplace transform. Okay, the definition of Laplace transform. So what I will do here, suppose I am writing here, L of sine square 2t. Then what will be this based on the definition of Laplace transform? So you need to move to your definition of Laplace transform, that is L of f of t is equal to by definition 0 to infinity e to the power minus at minus st into f of t dt. Okay, this is by definition Laplace transform is L of f of t is e to the power minus st ft dt. Now if you look at this definition, this right side and this question, you can see something common there. Is it? Means you are asked to evaluate integral 0 to infinity e raised to minus 2t sine square 2t dt. And here by definition of Laplace transform, the right side is 0 to infinity e raised to minus st ft dt. So here instead of e raised to minus, means here in this question, instead of e raised to minus st, here e raised to minus st, instead of that it is given e raised to minus 2t. Okay, and here f of t, so instead of f of t, here in the question it is sine square 2t. Okay. So suppose this is f of t. If this is f of t, if sine square 2t is f of t, so this is of the form L of f of t. So by definition what it is? Integral 0 to infinity e to the power minus st ft dt. Ft is sine square 2t dt. Okay, so that is now in the question, in place of this s, what you have? You have it as 2. Okay, so what we are going to do here is, we will evaluate this L of sine square 2t. L of sine square 2t we will evaluate, and then later we will apply the definition of Laplace transform. Okay, now we have the result 2 sine square theta. 2 sine square theta is 1 minus cos 2 theta, that is 2 sine square theta. Okay, so using this relation 2 sine square theta is 1 minus cos 2 theta. So here it is sine square 2t. So what I can write here? Here sine square theta will be 1 minus cos 2 theta divided by 2. Okay. Now instead of this theta, what you have here? 2t. So here instead of theta I have 2t. So here also instead of theta, what I will have? 2 into, instead of theta I have 2t. Okay. So this will be what? 1 by 2 into 1 minus cos 4t. So the sine square 2t I will be replacing by sine square 2t, I will replace by 1 minus cos 4t upon 2. So this is L of 1 by 2 into 1 minus cos 4t. This is equal to 1 by 2 constant. So we take it outside, 1 by 2 into L of, now take the Laplace transform inside, L of 1 minus L of cos 4t. That's equal to 1 by 2 into L of 1 is 1 by s minus L of cos 4t is s upon s square plus a square. Okay, so this is L of sine square 2t. Laplace transform of sine square 2t is this value. What you have got here, this is L of sine square 2t. Now look at the equation number 1. Equation number 1 is L of sine square t is 0 to infinity e to the power minus st sine square 2t. So either here LHS is this one and RHS is 0 to infinity e to the power minus st sine square 2t. So what I am going to do here is, I'm going to equate this LHS and RHS of this equation number, say 1 and say this is 2. So from 1 and 2, what we can write is this LHS is same, so both RHS of 1 and 2 will be same. From 1 and 2 I will write here integral 0 to infinity e to the power minus st sine square 2t dt. This is equal to 1 by 2 into 1 by s minus s upon s square plus a square. Okay, so RHS of 1 is this one, e raised to minus st sine square 2t, and RHS of 2 is this. Okay, so just we equated that. Now the question is, therefore question is evaluate 0 to infinity e to the power minus 2t sine square 2t dt. So what you have to do here is, here s is replaced by 2. So in the right side, instead of s, just substitute 2. S is equal to 2. So it is 2 minus 2 upon 2 square plus a square. A, what is a here? A is, and here also it is, sorry, instead of a we will write here, we have here 4. Okay, 4 square. So 4 square means 16 it will be. So here it is 2 square plus 16. So that's equal to 1 by 2 into 1 by 2 minus 2 upon 16 plus 4, 20. Or this is equal to, on simplifying, you will get this as 1 upon 5. So we will change this sine cube t first of all. So we use the formula sine 3 theta. Sine 3 theta is 3 sine theta minus 4 sine cube theta. So from this formula you have 4 sine cube t, means theta I am replacing by t. 4 sine cube t is equal to, means take this to the left side. It is 3 sine t minus sine 3t. And sine cube t will be then, sine cube t is equal to 1 upon 4 of this 3 sine t minus sine 3t. Okay, so this is the first step. So now again by definition, so L of sine cube t, L of sine cube t is equal to integral 0 to infinity, by definition of Laplace transform, L of f of t is 0 to infinity e raised to minus st ft dt. Ft is sine cube t dt. So keep it here. Now we will solve what is this L of sine cube t. So L of sine cube t is equal to, replace sine cube by the given formula, means we have written the formula here. So sine cube t is equal to L of 1 by 4 of 3 sine t minus sine 3t. Okay, then take Laplace transform inside, so that is equal to 1 by 4 constant. Now into L of 3 sine t minus L of sine 3t, or that's equal to 1 by 4 into 3 into sine t. L of sine t is 3 into sine t is, a is 1 here. So it is 1 upon s square plus a square, s square plus 1 minus, here a is 3. So it is 3 upon s square plus a square. So that's equal to 1 by 4 into 3 upon s square plus 1 minus 3 upon s square plus 9. This is what? This is our L of sine cube t. So like in the previous question, here again suppose I am taking this as equation number 2. Now from equation number 1 and 2, both LHS of 1 and 2, LHS of 1 and 2 is sine cube t, and RHS is given like this. So since LHS is equal, we can equate the RHS. So what I can do there is, therefore from 1 and 2, integral 0 to infinity e to the power minus st sine cube t is equal to, sine cube t dt is equal to 1 by 4 of 3 upon s square plus 1 minus 3 upon s square plus 9. Okay. Therefore, now our question is integral 0 to infinity e to the power minus 3t. So question is integral e to the power minus 3t sin cube t dt. So that will be given by replacing all s by 3. 3 upon 3 square plus 1 plus minus 3 upon 3 square plus 9. So that's equal to 1 by 4 into 3 upon 10 minus 3 upon 9 plus 9, 18. On simplifying this, you will get the answer. So it is, how much it is? 18 3s are 54 minus 30 divided by 10 into 18. So that is 24 by 4 into 10 into 18. You can simplify. That's equal to 6. Is 3 here, so it is 1 upon 30. If L of f of t is equal to f of s, and in some books you can see it as capital F of s, or you can see it as phi of s. Okay, so any you can use. So if L of f of t is equal to f of s, then L of f of a t will be equal to 1 by a f of s upon a. This is change of scale property. It means that is what we can see here. Here t is replaced by at. When t is multiplied with a, t is multiplied with a here in the left side. What changes in the right side? All f of s will change to function of s upon a. All s will be replaced by s by a on the right side, and it will be multiplied by 1 by a. This is called as change of scale property. So what you have to remember, if t is replaced by at, okay, L of f of t equal to f of s. So this t is replaced by at, then f of s, in f of s what will happen? All s will be replaced by s by a, and the total function will be multiplied by 1 upon a. That is change of scale property. For example, if suppose L of f of t is given, L of f of t is equal to e to the power, say e to the power minus 1 by s upon s. This is given. This is L of f of t. Okay. Now if I am asked to find out what is L of, say, f of 3t. So what happened here? T is replaced with 3t, or t is multiplied with 3. So as per our formula, this is as per change of scale property, all s will be replaced by s by 3. So here on the right side, here it is 1 by a f of s by a. So I will put here 1 upon 3 because a is 3 into all s is replaced by s by a. So it is e to the power minus 1 divided by s by 3 upon s by 3. Okay, so that is equal to 1 by 3 e to the power. Now e to the power minus 1 upon s by 3. So the reciprocal will come. This is minus 3 by s divided by s by 3. S by 3 also again you can write this as, again reciprocal will come here. 3, it becomes 3 divided by s. This s by 3 will change as 3 upon s. 3 gets cancelled, and we will get the answer as e to the power minus 3 by s upon s. So L of f of 3t is this one. This is equal to, what we have done is all s is replaced by s by 3 and multiplied by 1 by 3. So this is 1 by 3 into 20 minus 4s by 3 divided by, with simplification, it is a square by 9 minus 4s by 3 plus 20. Okay, so that is equal to, on simplifying this, you will get the answer as 1 by 3 into, means bit more when you take the LCM and all, it is 23, so 60 minus 4s divided by 3 divided by s square. Here denominator 9 is LCM, so s square minus 4 3 is 12s plus 180 divided by 9. Again, on further simplification, you will get the answer as it is 60 minus 4s divided by s square minus 12s plus 180. Okay. L of f of t is given. We need to get L of f of 2t. So as we told, it will be all s will be replaced by s by 2 upon s by 2 the whole square plus 4, and this will be multiplied by 1 by a, means 1 by 2. So it is s and 2 gets cancelled. So it is 1 by 2 here, s upon here s square by 4 plus 4, and on simplification you will get it as 2s divided by s square plus 16.